Right. So now let us talk about linear system of equation. Linear system of ODE. See, a general linear system of ODE, how does it look like? It will look like this. Y1 prime of, so let me just write down the most simplified version, yeah, that will be much easier to follow. A11 of y1 plus a12 of y2. Y1 aij's can be, may or may not be functions. Okay, aij's may or may not be functions. Clear? Okay, so y2 prime of x is given by a21 of y1 plus a22 of y2. Clear? So if you have something like this, so essentially that is if you have fi in our original definition, if you remember, x y y y1 y2. Okay, if that looks like ai1 y1 plus ai2 y2. Okay, then you have your system. Then the system capital Y prime of x equals to f of x y. Okay, with capital Y being y1 y2 y1 y2. Okay, is then the system this is called a linear system. Clear? Then this is called a linear system. Okay, now let's look at some properties of linear system. Now this of course we can change this thing, but this is not okay. See, this is a linear system in the sense that this is a homogeneous linear system. Yeah, you can actually add up a b1 of x over here and b2 of x over here. So b1 and b2 are independent of y1 and y2, but I mean independent means, I mean of course they are independent, but they does not contain, no y1 and y2s are here. Okay, it's just some function of x. So so in this case you can just write it like this. See, if you define capital A as a matrix which is a11 a12 a21 and a22, then see y prime, so y prime of x is essentially, how does it look? It looks like y1 prime of x, y2 prime of x. This is a11 a12 a21 a22, okay, times y1 y2 plus b1 b2. Clear? Okay, now that is the case. And so it's a small definition. If bi, so let's say if the small function b of x, if b of x, which is defined by b1 of x and b2 of x, okay, is equivalent to 0 0, then let's say call it 2, that's your 1. Okay, then 2 is homogeneous linear system. Okay, you guys already know that. Same thing here, homogeneous linear system. Okay, now if b of x is not 0, I mean 0 vector, clear, then it is, as you know, it is non-homogeneous system. Okay, important question, why do we study linear systems? Why we want to do it? Because you see, non-linear systems are difficult to follow, And what we do is most of the times we study linear systems and look at a nonlinear system in a small neighborhood in such a way that it will work like it will behave like a linear system. Okay, so that's why linear system is very important for us to study. Now another thing is this, see, system is the most so why study system? Okay, why study system? System of ODE. So the main thing is this. This is the most general version of ODE. Okay. So system of ODEs. So they are the general form. What do I mean by this? Let me write it. General form, and that is, any nth order. Okay, I mean, for now let's just call it second order, because we are just restricting ourselves to 2 cross 2. Any second order, okay, second order linear PDE, ODE can be written as a system. Okay, so but not the vice versa thing. Yeah, the other thing does not follow. So that is what. So essentially what I'm trying to say is this. See, first thing first is systems are very versatile in its own right. Okay, because they give you much more. See, it may happen that the phenomena which you are modeling, that may have 2 or more functions. Okay, but they are functions of one variable, but they are interrelated with each other. That is why systems are important. Another thing is, once you know how to work with systems, the second order linear ODE part, the theory of that actually comes as a subset of system. How? Because you see, so what I mean by this, so let's put a small lemma here. Okay, let's write it as a small lemma. So let's say that any second order linear ODE can be viewed as a 2 cross 2 system. Clear? And what I mean by that, so the proof of this is quite simple, but let me still do that part. It is, let's say, let's start with the second order linear thing. Y1 double prime plus a1, I mean, it can be function, it can be constant, I don't care right now. Y1 plus y1 prime plus a2 y1. Okay, let's say that you don't have to write y1, so let's write it like that. Everything is gone. So y prime plus a1 y prime plus a2y is equals to something. Yeah, let's say, okay, what do I put? A1 a2 a3. Yeah, let's say that. And for now let's just assume that ai's are constant. Okay, I mean, this is just for ease. Yeah, they can be functions of x, I don't care. So anyways, that's the point. Now what you have is, let v is to be y prime. Yeah? So you are defining a new function v, which is given by y prime. So y prime is your new function v. Yeah, of course, such a thing will I mean, I can do that. So once I do that, then you see, let's say this is your 3, then 3 can be written like this. If v is y prime, v prime exists, and it is given by v prime is minus a1 y prime, so which is v. Okay, which is v minus a2 y. Okay, y is what is y? What is y is y. Okay, so I can write it like this. No, I mean, I can just shift all of this together and I can write it like this. Now that's a system, right? How is it a system? So you see, I have two equations, y prime and v prime. Okay, and I can write it like this. Y prime is y v. So y prime is what? Y prime is v. So y prime is, if I am writing, this is 0 and this is 1. So you see, it is y times 0 plus v. So y prime is v. Okay, y prime is v. And here if I am just writing minus a1 and sorry, a2 and minus a1, if I write it like this, so minus a2y minus a1v. Okay, so v prime is this. Yeah, so that's a system. Yeah, one sec, let me just write it like that, a2 a1. Okay, so that's the system of that's a 2 cross 2 system. Plus of course, I mean, if you want you can just write it plus a3 is there, right? Yeah, I mean, of course that is there. So if a3 is there, how can you accommodate a3? Of course you can accommodate it. It is 0 a3. Okay, sorry about the noise. So essentially, how does it look? It will look like this. So let's say that is your capital Y of X. That will look like A. This is your A matrix. A times, so Y prime is A times Y plus B. Yeah, you can write it like this, where Y of X of course is Y of X and V of X, and A is given by 0 1 minus a2 minus a1, b small b, okay, is given by 0 a3. Clear? So all of these are matrices. Yeah, all of these are matrices, so we can just write it like that. And hence you understand that once I know how to work with systems, I can just take any linear ODE if I want, and if I know how to work with the corresponding system, then I know how to work with a linear ODE. Okay? So this is the reason why we study linear system of ODE. This is one of the reasons. Okay, right.